Alright, since the test was highly successful, we don't need to change the settings. If we would have needed to change the settings, then we would of course change the settings. Make a duplicate like this. If you hold the Alt key while clicking and dragging, you make a duplicate of it. And then delete the original one and Control P to print. Go to Setup, Continue, Preferences, and then change the pen settings. And as long as you're still testing, you can only change the value of the speed for the red one, but before you do the final print, make sure that you correct both of these if you have green and red values. Very good. In this case, the previous settings were more than adequate, so we'll just hit cancel here, and cancel, and done here, or cancel, it doesn't matter. It's the previously saved settings that are stored. Then we'll hide the test layer and show the other layers. Very good. And then Control P to print. And then hit print. Very good. And now with the actual file sent here, we can see, as previously described, that we have index 2. And we can go previous to the index 1 file and next one to the index 2 file. With any file that you have actually completely run, you can also see the time it would take to run it again. So here it takes 5 seconds. This one, the actual file, we have not yet run. So we will click Start and Stop to initiate it. Always make sure that you at all times are present in the digital fabrication lab when a laser cutter operation of yours is running. If you acutely need to leave the room, then you must pause the operation. You pause the operation. During an operation, the function 1 key serves as a pause button. So just hit pause and it will be paused and momentarily and temporarily halted, and now you can go to the bathroom or do that really acute matter that you needed to be done, but you must never leave the room when the laser cutter is running. Last semester there were 2 instances of fires developing in the laser cutters, thanks to students being in the room and actually reacting to this. No fire did spread and not even the laser cutters were damaged. But be present at all times. There is a controlled fire actively working its way through the material. And if there's a hiccup that makes the axis or the carriage stop and laser cut in only one instant, in only one position of the material, there will be a fire. You will need to be here to just hit the emergency stop button if it's critical, to just stop or abort to the toolpath here, or simply pause. It all depends on the severity of the incident that happens, but you need to be present in the room at all times to survey this. When you're done with the pause, you can hit the same button to resume. It's very important that if you press the start-stop button, the whole operation will be aborted. You will not be able to resume it. But if you press the function 1 key, you will be able to resume it. When the operation is done, the laser cutter will emit a beep and you know that it's done. The carriage will move so that this is furthest to the right position, and you will be ready to take out your material and clean up the work table. One thing to take note of here is that if there is plastic, then you would of course ventilate at least 5 minutes so that that nasty smell does not spread into the digital fabrication lab itself. Alright, in this case we can open the glass window. And then, if we would be fully happy with the result, which we are, but I think that I want to do 2 more copies of this same operation. So I will not turn off the laser cutter at this very instance. Instead, let's just do that. Actually, it only took not even 4 minutes to do one. So let's do twice more. With that file sent to the laser cutter, we can see that we have index 03. Very good. Then we'll just start this one. Alright, and after a little more than 7 minutes, 2 other instances of the original file was output as well. And now we are ready to, we should clean up and recover our material and so. But before that we can turn off the laser cutter. The laser cutter should not be on unnecessarily. So we can lower the bed to make it easier for us to recover the material. And then we can turn off the power to the laser cutter. We can do this 2 different ways. Either we do it the one way I prefer, on the wall, or we can do it on the power switch on the machine itself. Both ways are totally fine. If you turn it off on the wall, it is more evident for me as a workshop technician when I make rounds and make sure that laser cutters are turned off for the evening and so, that they are. But if you are even the slightest bit uncertain whether you are switching the correct switch or not, then of course it's a more safe way to turn off on the machine itself. Then you cannot by mistake turn off another student's machine. But I will turn off on the wall here. Very good. And now, with a whole different noise level, we can carefully open the glass window and remove the large part of the sheet here. Let's see if we can remove as much of it as possible by gently wiggling it. Let's see if this one wants to get out as well. Not completely. Let's see here if we can force it out. Yeah, so then if it doesn't get out the full way like it didn't here, then it might be good to actually lower the speed a little. To lower the speed, now it was 10%, so perhaps to 8% or 9% even. Let's see if we can do it like that. And here's an important thing. I do understand students' willingness to preserve material for other students to use, and I totally support that. But make sure that you adequately prepare the material for reuse then. If you want to donate, say, this sheet, please don't leave it in the digital fabrication lab like this. Make sure that you either go to the mechanical scissors in the computer lab and just take away this part that cannot be reused by any other students, and then leave this part for reuse. Don't leave it like this, please. It took me exactly 1 minute and 7 seconds to go with the piece of waste to the mechanical scissors and make a nice residual reuse cut. If you really care about reuse, then please transform your waste into reusable material. Now, when you are ready to extract your material, make sure that you remove all of your material from the work table. That includes any waste that you will have to clean up. So in this case, yeah, I'll just remove the elements which I'm actually interested in keeping. And I'll bring these to the space by the computer that I have booked. And then I think these pieces are large enough to be cleaned up by hand. If you would have very many small pieces, then it might be more beneficial to use the vacuum, and I can actually show you how to do that as well. But then we'll have to get rid of the large pieces that the vacuum anyway can't effectively suck up without clogging the hose. So we'll do like this and like that. Alright, if you would have left lots of residue beneath the work table, I can demonstrate how you clean up this mess as well. This vacuum machine might be found at any place in the digital fabrication lab, depending on where the previous user has left it. But take it and connect it to a suitable power socket. I will use this one. And with it connected, just more than a parenthesis, but something to take into account, is that this hose extension is here for a reason. If this is detached, then the inlet is wider than the hose itself. So it will eventually collect materials that clog up the hose. So this extension is used to make sure that no pieces of elements that it sucks up actually clogs the hose. So keep it on, please. It also makes the suction more efficient. To turn on the vacuum machine is easy, but it's a little finicky anyway. The power, or like the gradual power, is adjusted with this one. I usually do max. And then you turn the knob here from 0 to manual. And it will turn on, not this one of course, it's only the extension of the hose, but it will turn on the machine. And as you might have noticed, it started to shut off. It will do that. What usually is done is to just turn it to 0. You just turn the knob to 0 and then again to manual. There are still a significant amount of waste underneath the work table, but this is not about eliminating all of that material, it is about reducing it. That material, which is lying underneath the work table, will be recut and recut and recut, and that leads to an unnecessary increase in smell that emits during operation. So please clean after yourself, but don't feel an obligation to clean it 100%. When you are done, simply turn off the vacuum machine and gently take away the power cord from the power outlet, and then reposition the vacuum machine. Before you leave, make sure that you sign out of the computer here in the Digital Fabrication Lab, and also that you take with you everything that you brought in here. If you are the last person to leave the room, then make absolutely sure that all 3 knobs on the wall, the power knobs to the laser cutters, are turned to their off 0 position, and that you also turn off the lights. Thank you. Now, this is more of a bonus than anything else, but let's see how this actually assembles. Alright, in my opinion, the tolerance that we chose for the inner holes, I think it was 0.25 millimeter offset, so that amounts to a total of 0.5 millimeter along each axis. It was a little too much, because there is not much rigidity in the construction as of now. Perhaps if we make a cap as well as a platform, and make sure that those keep the bottom and top tight enough, then I think it is perfect, but not as it is right now. Alright, but thank you for following in this journey from digital 2D and 3D modeling to digital fabrication with the laser cutters. Thank you for your time.